All right, so let's go ahead and start our Unit 1, Part 2. So it's still algebra review. There's just a lot of topics to review from Algebra 1 and 2. Next, we're going to take a look at exponent rules. So, and we've talked a little bit about exponents anyways, but an exponent, this is your exponent here. Here is your base. And the exponent's going to tell you how many factors of your base you have that you're multiplying. Okay, first we're going to rewrite expressions. Pay attention to commas. So in example 1, rewrite each expression using algebraic notation. X to the 4th power, comma, plus 5. So X is being raised to the 4th power, and then you're adding 5. Part B, the 4th power of the quantity. A quantity is going to imply parentheses. So the quantity X plus 5 is together, it goes first, and it's the 4th power of the whole thing. Here with the comma, it's saying X plus Y, that goes together, comma. So once again, this is X plus Y to the 4th power. So it's forcing parentheses there with the comma. X plus X to the 4th power. So X plus X to the 4th power. Right, exactly as it is. You don't need to put any parentheses in. No commas, no word quantity. Things like that are going to tell you to put in parentheses. Okay, so all of these, again, are review from Algebra 1 and Algebra 2. So when you multiply, you add exponents. So 5 plus 4 means we're going to have 9 3s being multiplied. So 3 to the 9th. Don't actually do 3 times 3 because you'd be introducing a new 3. This should not be a 9. There's 9 3s. Next one. You can multiply 4 times 3. They're not connected to exponents. 4 times 3 is 12. The A's are connected. We have 6 and 5 of them. So if you add that up, that's 11. Same thing with quantities. Notice we have 1 x plus 1, and then we have 2 x plus 1. So altogether we have 3. So x plus 1 to the 3rd. Next rule, when you have a power to power, you multiply. So the base stays the same. 4 times 3 is 12. And you could calculate that on your calculator or keep it like that. For the next one, this squared, you're going to square each part inside. So the coefficient 5 is like saying 5 squared. And then the A is like saying A 6 times 2. So if you simplify that, 5 squared is 25. 6 times 2 is 12. And a lot of people will just simplify it right away. I'm fine with that. Next one, we have 2 quantities of x plus 1 to the 3rd, which means we end up having 6 of them. So you have x plus 1 to the 6th power. When you're dividing, you subtract exponents. If you always do top minus bottom, you could get positive or negatives. Or you can ask yourself, which one is bigger? Wherever the exponent is bigger, that's where the variable's left over. So in number 3, the first one, 12 divided by 2 are just normal numbers, not exponent rules. 12 divided by 2 is 6. Then we have a to the 6 over a squared. 6 minus 2 is a to the 4th. Yeah. There's more a's on the top. There's 6 a's on the top. So they're left over on the top. And you can draw a quick sketch if you wanted to. Notice those cancel. The 4 a's are on top. Next one, 11 over 22 is 1/2. Then you have a cubed over a to the 9th. There's more on the bottom, so the leftover ones are on the bottom. How many are left over? 6. Or you could do 3 minus 9, top minus bottom, would give you 3 minus 9 is -6, and then because it's negative, it goes down. Either way, you get the same answer. Next one, a to the 5th over a to the 5th. I have a lot of people just cancel this out and say it's 0. It's not 0 because the coefficient in front is 1. 1 over 1 is still 1. Yes, there are no a's left, but you still have the number 1. Next one is this power to power, which we kind of looked at a little bit above, but it's true also with fractions. You want to raise that power to each part. So we have 2 to the 3rd, and then we have x to the 2 times 3. So 2 to the third is 8. 2 times 3 is 6. Next one, this squared is going to go to all parts. There's 3 parts. So you have negative 3 to the second. And then you have 3 times 2 is 6. And then 1 times 2 is 2. That b has a 1 there. Negative 3 squared is a positive 9. See how the negative 3 was in parentheses? So when you square it, it's negative 3 times negative 3. If you used your calculator and you don't use parentheses, it will mark you wrong. All right. Next one. This fourth power is going to go to all parts again, numerator and denominator. So you have 3 to the 4th, x to the 8th, over y to the 12th. 3 to the 4th is 81. X to the 8th over y to the 12th. Final answer. Okay. Ah. The 0 exponent rule, again, we've talked about anything to the 0 exponent is simply just 1. 10 to the 0 is 1. This whole quantity to the 0 is 1. Now, this one you have to be careful. The only thing attached to the 0 is the x, not the whole quantity. The 5 does not have a 0 exponent. So x to the 0 is just 1. So it's like saying 5 times 1, which is just 5. So x to the 0 means there's 0 x's. Just the 5 is left. Okay, negative exponents. If something is negative, you can move it from the numerator to the denominator. Or if it's negative on the denominator, you can move it up to the numerator and make that exponent positive. So 5x to the negative third means you only move the x part down. The 5 is not attached to the negative 3. Done. Next one, all parts are being raised to a negative 3. So there's more than one way to do this. You could take each part separately and do your power to power. And then because they have negative exponents, move them down. 6 cubed, I believe, is 216. Yep. And that's one way to do it. Or the other way to go ahead and do it is, and I'll keep the answer up, because this whole thing is being raised to a negative exponent, you could simply bring the whole quantity down and raise it to a positive cube. And then you could go ahead and do your power to power. So you'd have 6 cubed, x to the 12th. 6 cubed is 216, and you'd get the same answer. So again, 2 ways, it does not matter. Next one, 10 over 20 are just normal numbers. 10 over 20 is 1/2. X to the negative 6 has a negative exponent, so it goes down from the numerator, from the denominator to the numerator, and goes positive. You don't have to have the 1 there anymore, but you could keep it if you wanted. Typically, I have my students do a lot of these problems during class, because again, this is the 3rd time. So example 2 is just kind of when you have more things going on. So we've got 4 examples here. For the first one, because this is being raised to a negative 1, I'm going to go ahead and move the whole thing down. So really, this problem is 5a squared b cubed over 3a to the 5th b. Now I have all positive raised to the positive 1, but anything to the 1 doesn't change it. So I'm just going to keep it like that. 5/3 does not simplify. A squared over a to the 5th, there's more a's on the bottom, 3 left over. B cubed over b, remember this is like a 1, so 3 minus 1 means there's 2 left over, and there are more left on the top. Next one, we're multiplying. 6 times 3 is 18. X to the negative 4th times x to the negative 6. When you're multiplying, you add exponents, so that's x to the negative 10th. And then for my y's, y times y to the negative 3rd. Remember, this is like y to the 1st. When I multiply, I add. 1 plus negative 3 is negative 2. Then anything that's negative, I'm going to move down, or anything, yeah. So this is going to go down, and this is going to go down. 18 does not. 18 does not have a negative exponent. So x to the 10th, y squared. Is this the only way to do it? No. Could you have moved your negative exponents right away and then simplified? Yes. but I multiplied and then moved my negatives. Again, you could have moved your negatives and then simplified and did your multiplication and division. Okay, next one. I'm going to go ahead and do the power to power first to every single part on the numerator only. So 2 to the third is 8. 2 times 2 times 2. 4 to the third is 12. And negative 2 times 3 is negative 6. I am choosing not to do anything with the bottom yet. Now I'm going to move any negative exponents. So I'm going to move this down. And I'm going to move this up. So I really have, first of all, 8 over 8 is gone. It's just 1. So I have x to the 12th, and then my y's flip because they're both negative. Now I'm going to simplify. X to the 12th over x is x to the 11th. They're left on top. Y to the 6 over y to the 6th cancel. There's 0 y's left. So it's just simply x to the 11th. Again, not the only way to do that problem. Okay, part D. I am going to first simplify in my fraction, then I'm going to do the cubed power. But I know some students like to take this to all parts. That would be 7 parts. Again, I'm not going to do that. I'm going to simplify within because parentheses, PEMDAS. 12 over 3 is 4. And then I would say, oh, a to the negative 5th comes down. So I have a cubed and then a to the 5th. B squared stays. C to the 0 means there's 0 c's. And my b to the negative 1 is going to come up. I'm still going to simplify my parentheses. B squared times b is 2 plus 1 is 3b's. B cubed. A to the 3rd times a to the 5th, I add the 3 plus 5 is 8. Now I'm going to go ahead and cube it once I simplified. Again, you could have cubed in the beginning. I just think this way causes less errors. So 4 to the 3rd power, not 4 times 3, 4 to the 3rd, 64. Now here's an exponent. 3 times 3 is 9. And power to power, 8 times 3 is 24. That is my answer. I'm done. Okay, that is it for your review on your exponent rules.